Hi everyone, in this video I'm going to do what I did in lesson 1.5, meaning I am going to walk you through the vocabulary and kind of just give you some extra explanations and connections between the ideas, the shapes that we're talking about. So we talked about a couple lessons ago about what is a polygon, and then of course a quadrilateral is any four-sided polygon. So today we're going to look at, in particular, specific types of quadrilaterals. The first type of quadrilateral we're going to look at is we're going to look at a trapezoid. And a trapezoid, again, is a special type of quadrilateral. So we have like the general types, and then we have some more specifics. A trapezoid is formed when we have exactly one pair of parallel sides. So this is an example of a trapezoid here. We can see that with those little arrows there, that is telling us the sides are parallel. And only one set of the sides are parallel. So the other two sides can be kind of sort of anything, but they're not going to be parallel to each other, and that's the big distinction. What I want you to remember here as well is the idea of what is a definition versus what is a property. So the definition of trapezoid is a quadrilateral with exactly one pair of parallel sides. And later we're going to learn about some properties of trapezoids. We're also going to be talking about something called isosceles trapezoids, which have some unique features as well. The next type of quadrilateral I want to talk about is a kite. So a kite you might be familiar with just from knowing what kites look like in the sky, like the toys. But a kite's definition is a quadrilateral with two distinct pairs of consecutive congruent sides. This is our picture of our kite. So we have this set of congruent sides and this set of congruent sides. Remember how we talked about a definition classifies and differentiates. So if we don't have the word distinct here, if we say a quadrilateral with two pairs of consecutive congruent sides, can you guess what quadrilaterals also fit that bill? The answer is going to be below: rhombus and square. Now the interesting thing is, because a rhombus and a square also have two sets of consecutive congruent sides, they actually have some properties in common with kites, which we will talk about later. The other thing I want to talk about, although you don't have to know this, is the idea of what something's called a dart. So a dart is a concave kite. Now we talked about what convex versus concave means, so we're working with convex polygons right now. But if I drew a concave kite, so I have these two sides are congruent and these two sides are congruent, this is actually called a dart. So it sort of looks like an arrow. We don't do much with them in this course, but something I thought I would mention. So trapezoids and kites, when we're thinking about the giant umbrella of quadrilaterals, they are sort of two distinct sets. However, our next list of quadrilaterals all fall under a general category, and that is called parallelograms. So a parallelogram is a quadrilateral with two pairs of parallel sides. Trapezoid, one pair; parallelogram, two pairs. And these two pairs are the opposite sides. So this is what makes a parallelogram a parallelogram. You might be also thinking about things you know about a parallelogram, some of its properties, like I said. For example, the opposite sides are congruent, or something to do with the angles. But that's not the actual definition of parallelogram. So parallelogram is a general term for a quadrilateral with two pairs of parallel sides. And then what we can do is we can take the parallelogram and add some additional features and get some extra shapes. So for example, if we take a parallelogram and we make all the sides congruent, so if we have an equilateral parallelogram, So think about taking the parallelogram and sort of squishing it. So the top two sides are also congruent to the opposite two sides, or the top and bottom. It's not really a top and bottom. Then what we end up with is a rhombus. Again, a rhombus also has some features that a kite has because it has two sets of consecutive congruent sides as well. If we took a parallelogram and sort of straightened it up, okay, so if we took our parallelogram and instead of it being tilted, we sort of tilted it upward, we would end up with a rectangle. So a rectangle is an equiangular parallelogram. Now, notice that I didn't tell you all the sides were right angles. I just told you that it is equiangular, although it does, because they are all congruent, and we will find out later on that a quadrilateral must have 360 degrees. It is a parallelogram where all the angles are right angles. Finally, if we take all the features of rhombus and all the features of rectangle, which again have all the features of parallelogram, we end up with a square. So a square is a regular quadrilateral. So it is both equilateral, like a rhombus, and equiangular, like a rectangle. Again, regular polygons are equilateral and equiangular. What this also means, you know, a lot of people say a square is a rectangle, but a rectangle isn't a square, right? So when we talk about naming something, we always give it its most specific name. So if we have a square, yes, it is a rectangle, but we call it a square because that is the best name for it. That's giving us the most specific names. But we also want to remember that we don't want to read into a shape. So just because if something looks like a square, if I haven't labeled and marked all the angles congruent or all the sides congruent or the opposite sides parallel, then we don't want to read into that either. Also, as we're doing our investigations later on, if we're looking at things that just apply to a parallelogram, we always want to remember to draw the most generic parallelogram we have and not a specialized shape, because we want to make sure that we're getting the ideas that fall just under that particular shape, not something that's even more specialized. So that's all I have here for this. And I strongly encourage you to work on the homework as well as that extra worksheet that I have that works with concepts from lesson 1.1, 1.4, 1.5, and 1.6. So great job with this vocabulary.